Here's part 2 of your Chapter 4 study guide. For number 11, you were asked to compare two water tanks draining from two separate stations. We're comparing an equation that's given to us and the graph that's given to us. Question A reads, which water tank is draining from a higher volume? That's where the graph begins, or the y-intercept. So in our equation, the y-intercept, or the initial value, is 350. In the graph, the water tank is draining from the beginning value, or the y-intercept, of 250. So which water tank is draining from a higher volume? That would be tank A, because its beginning, or its y-intercept, is 350. Question B says, which water tank is draining at a faster rate? Rate is also the same thing as slope. So now we're going to compare the slope in the equation to the slope of the graph. The slope in the equation is found right here. The slope is -15. The slope of the graph is rise over run, so we can pick two good points and rise and run. I'm going to select this point and our y-intercept to make the right triangle. Rise over run. It looks like it's rising one block, and one block is equivalent to 50. And then it's running a block, and let me see, this seems to be going 10, 20, 30, 40, it's going by 10, so 50 over 10, and this slope is negative. 50 divided by 10, that can simplify for a slope of -5. So which one is draining at a faster rate? Which one's emptying faster? That would be -15, also tank A. If we saw that on a graph, this would be sloping steeper. So tank A for both question 11. Question 12. Two containers, P and Q, are filled with different amounts of water. Each container has a small drainage valve. The graph shows the amount of water left in each container after X minutes. Part 1 says find the initial amount of water in each container. The initial amount is the y-intercept. We can find that on the y-axis. So container P looks like the initial value is right here. So for container P, the initial value is 1,000 milliliters. The initial value of container Q can be found right here. So the initial value of container Q is 800. Which container has the biggest drainage valve? So that is asking which one is draining at a faster rate. For that question, we have to find the slope of each container and see which one is draining faster. I can kind of see it in the graph. It would be the drain, or the line that is draining at a steeper rate, or the steeper slope. So I'm thinking that it's container P because that's a steeper valve. But I'm going to go ahead and verify that with the slope. So my next step is to look for two good points on the graph. I'm going to use this point of intersection here as one point, and then the y-intercept to make my right triangle. Okay, so this is container P. Looks like the slope's like it's going up by 100s. So 100, 200, 300, 400, 500, 600. It's rising 600. And then it runs 40. 1, 2, 3, yeah, 40. And 600 divided by 40 gives this a slope, a negative slope of 15. So our slope, it's draining at a rate of 15 milliliters per minute. Now I'm going to do the slope of Q. So I'm going to use that same good point and then rise and run. And let's see, this rises 100, 200, 300, 400. And it's running the same, 1, 2, 3, 4, over 40. And that simplifies to a negative 10. So which one has the biggest drainage valve? If I compare the slopes, the steeper one is going to be P. I could also have checked the steepness of the line, but it's good to have a mathematical justification to your answer. Question 13. Mobile provider P and Q each charge their customers C dollars. Each charge consists of a monthly service charge and a fixed usage charge per minute, T. Which provider charges the greater amount of money each month, and explain what information is used to determine your answer. So since they charge a monthly charge and per minute, we can find the monthly charge right here, the initial value. So looking at the initial values, it looks like company Q initially charges $40 and company P initially charges $20. So who charges the greater amount of money? Company Q. What information did I use? I used you could call the y-intercept or the initial value. And then I would explain that. So I used the y-intercept. So your explanation should have something to do with using the y-intercept to find the initial charge per month. Part B, which mobile provider charges the lesser per minute fee after 50 minutes of time? The key here is we have to be looking after 50 minutes of time. So if I go to my graph and I want to find the per minute charge, I'm going to be finding the slope. So I need to go to the graph and find the slope of each line after 50 minutes. So I have to find some good points. I'm going to start right here on line Q and go to here, rise and run. So this is rising by units of 10, line Q. So it looks like it rises 10 and then it's running 50. And 10 divided by 50 is 20 cents per minute for line Q. Let's look at line P. I'm going to do the same 2 points after 50 minutes. From P, I'm going to rise and run to those 2 points. So that one you can see for line P rises $20 for 50 minutes. So that's a charge, 20 divided by 50 is 40 cents per minute. So the question is, which mobile provider charges the lesser per minute fee after 50 minutes of time? That would be Q. Part C asks, at what time are both of the mobile providers charging the same amount? The same amount, so we're looking for the same amount that they charge. That looks like it's right here where they overlap, and that would be at 100 minutes.